Okay, so today is on vectors. So vectors is going to be kind of a foreign language to you. So I want you to be real careful here. Let's see what set of notes I'm going to use here. I need to get my story straight. So when I went over this, I was trying to make notes to myself on two different note packets. So I apologize if I keep going back and forth. So that's me not having two different packets that I was using instead of just one. Okay, so a vector. A vector is just a line, and this is what it looks like. So your vector looks like this. Doot. And then it has like a variable underneath. This is the sign for a vector. You will also see vectors in these little bracket things. So just FYI. What else did I need up here? So a vector is a directed segment representing a quantity that has both a magnitude, length, and a direction. So the magnitude is the length of a vector found by using the distance formula. So we'll need that. The direction is the measure of the angle that a vector forms with a positive x-axis or any other horizontal line. So this is what this is going to look like. So you're looking at, like if a vector is going here, you're trying to find this angle from here all the way to here. So that's a vector, trying to find that. A vector component form is a vector expressed as an ordered pair. And again, that's where you see the change in x and the change in y. So that's different than slope or the constant rate of change. So that's what that looks like. All right, so vector addition. So when you have two vectors, so this is what a vector looks like. You have A, you have B. So to find the result of A and B, use one of the following methods. We'll use that one in a minute. So on this one, all you're going to do is you're going to continue this together until they meet up, and then you'll have this line that's going through, like that. Okay, so that's A and B together is this line. Okay, so you can complete this parallelogram. So all your sides would be equal. So this side is going to be equal to this side would be equal to this side. This is one we're not going to use. So I was thinking about this one, but I don't think we're going to use that. So we're just going to get rid of this for now. All right, so let's do a picture of this one. So when you're adding them, this is so easy. So when you're adding them, we're literally going to make those touch, and then we're going to send an in-between. So in our in-between, we need to make sure, maybe I should have gone further, because I want this side to be the same as that side, and then this to be the same as this. So you make that parallelogram. So this side and this side should be the same, and this side and this side should be the same. Now when you subtract them, all you're going to do is, so you have your A, which is going this way, your vector A. Your B is you're going a different direction, so it's going to the opposite direction. So your vector is going to go this way. So your vector B. And then you want this line that's going through, that's going to make that parallelogram. So So this side again is the same as this side is the same as this, but yet we reverse the direction of this vector. I know, again, like I said, it's probably like a foreign language, but let's keep going. Multiply both. Okay, so again, these are little vectors because you've got these. And this is if it's scalar, meaning dilation. Okay. You can even combine scalar multiplication with a vector addition and subtraction, which we're going to do here. 2, 3. Like I said, I'm all over the place. Okay. So, when you are adding your vectors together, it's written like this. This can also be true. So this goes with him. He could go with him. When you're subtracting, the same is true. You're going to be subtracting these two, and you're going to subtract these two. This would be like your final answer. Again, different language, and you need to see it in action. This is the scalar, so you're multiplying. It's like the dilation, so you would multiply both of these things almost like the distributive property. So, doot, doot. Okay, so here we go. Let's see this in action. So if you have these two vectors, so this is a vector. So the vector means like if it was in a coordinate plane, it's -1, 3. So you're going from here to up here to 3. That's what your vector is. Something like that. Okay? Your other vector is doing this. We're going to find when you multiply this first one by 3 and add the second one. So you're going to say 3 times my vector of 3, -1, plus this vector, which is y, 1, -2. This I'm going to distribute, so this becomes 9, -3, plus 1, -2. Now we're going to put these together. Just like here, we're adding. So we're going to add our A and our C. So this plus this. So 9 plus 1, should I write that out? And -3 minus 2. 9 plus 1, I'm running out of room, is 10. -3 take away 2 is -5. So there is my final answer. Told you it was weird. Okay, so here's the vectors. So, and they've got your point. So you're going from here to here, that's your vector, and you're trying to find the component form of it. So again, it's the change in x and then your change in y. So you're to go from, it's kind of like slope-ish, it's just backwards. So it's the change of x. So this is your x movement. So you're going this direction, 3. And you're going this direction. Did I do that right? 1, 2, 3. I'm sorry, that direction 4. And then you're going up 1, 2, 3, positive 3. So that's what it is. Okay. Let's try this one. So dot, 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 dot. This way, plus 2. I always want to put a plus sign there. And then dot, 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 and you're going up 1, 2, 3. So that's the component form. 1, 2, 3, 4. See, I'm not reading these right. It's 4. I need to count those humps all the way to the top. All right. Magnitude. This is where it gets kind of crazier. So let's do our vector. So we're just going to plot this. So, and you're starting from here, starting from your origin. So 7, negative 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. That is that vector. Going that direction. Okay? So that's how you start it. Now we need to find the length of this. So this is a hypotenuse. So that is where your direction is going to be your degrees. Like I said, it's going to be your degrees from here. So let's start here and go counterclockwise. So I'm going to go all the way to here. So how many degrees is that? Hopefully you know from this to here is 90, 90, 90. So we already have 270. Plus whatever this amount is. The other thing we need to do is we need to find this length here. So to find that length, we can use the Pythagorean theorem because it's our hypotenuse. So basically, this was 7 and this was 5. So 5 squared plus 7 squared equals, the magnitude is going to be the Pythagorean theorem. Calculator. 5 squared plus 7 squared equals, and then the square root of 74 is my answer. And that's my magnitude. I am all over the place. My degree, so we know that's 270. So how do you find this degrees? If you would look at this, this makes a 90-degree angle. How do we find an angle based on what we have? Hopefully you said trigonometry. So that's how you find the missing angles. So what we would do is we would say, so we're trying to find this angle, so we know this opposite is 1, 2, 3, 4, 5, 6, 7. So the opposite is equal to 7. And then we know this adjacent here, 1, 2, 3, 4, 5, is 5. Which one is opposite adjacent? Tangent. So we would say tan -1 equals 7/5. I don't know why I always say equals, but you're multiplying that. So in our calculator, we're going to say our tangent on clear. Okay, so -1, the inverse, 7 ABC 5 equals 54.5. I'm going to say, or we could just round it to 50. Does it say where to round? No. So we're going to round it to 54. 54. So that means that degrees is 54. So we need to add that to this. So it's all the way around. So 54 plus 270 equals 324. And that is our direction. In degrees. Yes, it was a lot. Not bad, but a lot. All right, so let's try this again. So -4, -4. Here's our vector. Again, we need to get the degrees all the way to here. This one's 90, this one's 90, so we already have the 180, plus whatever this is going to be. And then we're going to use the Pythagorean theorem for this guy here for our magnitude. So my magnitude is equal to, what is that? 1, 2, 3, 4, 1, 2, 3, 4. So 4 squared plus 4 squared equals c squared. 4 squared plus 4 squared is 32. So c is equal to the square root of 32. That's our magnitude. My direction, we're going to take the tangent again, because we know the opposite and we know the adjacent to here. So which is 4 over 4. So tan -1, 4 over 4. Let's do that one. 4, ABC 4, gives us 45 degrees. And then when I add these two together, 45 plus 180 gives me 225. I'm trying to see where I could squeeze this in. And this is our direction. Holy cow, and then this was the magnitude. All right, I think that's it. If you guys need me, you know you can reach out. Please, please, please feel free to do so. So, anyway, that's it.